And the construct validity is a judgment about the extent to which interventions and measured variables actually represent targeted theoretical underlying psychological constructs and elements, which is concise and elegant. Now, simply put this way, if your construct is good, there's an increased probability, not a guarantee, but that you'll have a valid instrument. So if I'm measuring, let's say, how well someone does on a foreign language learning aptitude test, then that person should be able to get another language, learn another language well. It isn't a guarantee, but if the construct, the underlying thing that I'm trying to test in this is good, there's a high probability that they should correlate properly. Now, there are three threats to construct validity. Inadequate explication of the constructs, mono-operation bias, and mono-methods bias. First, we'll talk about inadequate explication of the constructs. Thank you. Okay, simply put, if you don't know what you're trying to test, it's hard to test it. That's an important point. If you don't have something like language acquisition that's properly defined, then it's going to be hard to build a test that gauges that. If you're trying to test any kind of ability and you don't have a good, and we talked about operational definitions, then it's going to be very difficult for you to make the test functional.
All right, now if you would wait just a second.
Okay.
Do you remember the lines, operational definitions?
Yeah.
If you were to track in parallel, remember how that was kind of outlined? There would be sections on demographic controls and then educational identity and school identity, and so there were different sections all outlined. That outline followed the figure in chapter 1, the different kinds of variables that are listed there. And that also tracks in chapter 3, which in her case is about 60 pages long. Normally that's only 15 to 20 pages. But because she was dealing with so many concepts, many of which she was creating herself, she has in parallel to the same outline where each of those variables, the literature on that is explained. So she's got anywhere from a paragraph to two or three pages on each of the concepts or each of the variables in that outline, and she talks about them conceptually and from the literature in chapter 3. So she has all of that explanation in chapter 3 that parallels the actual operational definition in the appendix. A lot of people don't do that, but in her case she did.
Well, and this is, I know that as a lot of, I know I've got a teacher here, a teacher, gosh, I don't know, are either of you teachers?
Yes, I am.
You are? Okay, so let me ask this. Are any of you ever given any concepts that you're tested on or that your students are tested on that you don't really understand what they are? Does anything like that ever come to mind? Anything like that?
Not usually.
All right, well, I mean, if not, that may be the case. But sometimes you will see constructs that are poorly defined or where there's not really much of a definition.
Okay, the new science standards, when they originally came out, before they were adopted, were very difficult for the elementary students or teachers to.
Oh, that's interesting. Did they not understand what they were supposed to do or
Yes.
what the purpose was?
Yeah.
Well, anything like that would make it harder to measure.
Anything that's vague
Yeah,
is more difficult to measure.
they've straightened them up.
Oh,
Yeah.
well, that's better late than never. All right. Well, okay. So then we'll go on to the next one, which is mono-operation bias. Now, if you only deploy an intervention once, or when only one example of a dependent variable is given, the conclusions that researchers may draw from an experiment may be limited. Okay, let's take an example here. You're teaching students who have maybe some literacy problems, that their performance is not up to what you want. You teach them it's a single shot lesson on phonics. Okay, now they're hooked on phonics. They broke into a car, they stole their mother's jewelry. It's just a nasty path that they're going down since they're hooked on phonics. Nobody gets that joke. Never mind.
No.
Thank you for the
I get it.
obligatory laugh. That's why it's an obligation. It is obligatory. Thank you. Like I told my students, laugh or you fail. I wasn't joking, but they did laugh. So anyway, if I give a one-shot treatment, there are obvious problems with that. And one operation, if it's one-off, that really doesn't demonstrate much of anything necessarily. You need repeated operation, and really you're going to need to try to probably deploy something different ways, and we're going to get to that one next, which is monomethod bias. Okay. If you're teaching something only one way, or you're only using one method of doing something, then you're really only testing that one method. Doesn't mean that your conclusions will be wrong. However, it does mean that you're going to have limitations as to the kind of conclusions you can make. If you only know that a certain teaching method, that teaching a certain thing works in a certain method, it's not generalizable. You cannot generalize it. Excuse me, it is not generalizable. So, that could be an obvious problem, not because the study's bad, but because the study may be very, very narrow. Okay. Now, there are other ways of teaching phonics, and we could go on with that. You might, for instance, use computer-based training, workbooks, discovery learning. Has anyone heard of what discovery learning is? Is that done ever, actually?
Especially science,
It is.
math,
Science and math would be the most common.
Okay, not so much literature reading stuff.
Not as
That's
No,
more
that's not.
structured. Okay. Well, you see, all right, well, that's good.
Social science sometimes.
Social science, okay. So it can be used. All right. And that would be maybe a different way. Maybe kids can learn and discover their own rules, see patterns in speech, and use that to help them figure out how they're learning. That's a possibility. Then we move on to is it now Z's turn? I think at this point
Yep.
we're on to internal validity. Means it's Z's time.
Thank you very much.
Okay.
Pretty much what we covering just theoretical.
Oh, you need it.
We got.
Thank you.
Is it already on?
Basically just wearing those for decoration, I don't think they're working.
I think it adds to your outfit. It's all
Yeah.
good.
it's good.
Okay. Straightforward concepts here. There are actually two major broader categories of threats to validity, and the first one is internal validity. And it says here that this is the degree to which research design rules out other possible explanations for a study's finding. And basically that is clear cut. All it's saying is that every possible loopholes that could give your findings some alternative explanation supposed to be done away with, so that your findings will be geared towards, will be credited towards just your internal research. So in this case, you want
Remember, notice he just used the term alternative hypotheses. Alternative hypotheses, threats to validity are really synonyms. Threat to validity really is an alternative explanation or an alternative hypothesis for the results that you got.
That makes sense.
And normally, if you assume internal validity, you assume that whatever you're studying is the cause. Almost all of the threats to validity would be a weakness in the design, so that there could be some methodological explanation for it, and that you're trying to rule out all of those methodological loopholes. So that's another way of thinking about that. Loopholes, that's another word you used, that's right on target.
And then we have history to be the first threat we want to discuss here to internal validity. And all this says is extraneous events, circumstances, anything outside of what you are doing that encumbers your research. Maybe it could be like snow days or anything that impedes progress. My favorite is maybe your college won the NAACP basketball championship. You know, everybody will be hyped up, and as good as that is, and it's going to hinder it has the possibility to hinder your research because maybe people's minds will be all about basketball at that time. So momentarily, that could have some distraction, and it may affect the validity of your studies because people may not have their minds fully concentrated on the event or the research being done.
By the way, some of those are much bigger than others. You remember 911? Anybody that was doing a study of current events or history, government, anything related to that during that period, any possibility of claiming that your results were solely related to what you were doing would have been shot down by the threat of history due to the effects of 911. See, so some of those historical threats would be much bigger than others. And 911 would have been a serious historical threat to anything related to any kind of curriculum development.
Okay, selection bias. Anything that does not give your groups an equal start, to put them both on equal footings, renders there's bias. It has to be a bias if the two groups are not equal to begin with in the first place. That's what we say here. A group of high school students is trained using a new teaching techniques. They are compared to a group of graduate studies trained in using a traditional technique. The lower performance of the high school students is incorrectly interpreted to demonstrate the ineffectiveness of the new technique. So to start out with, the grad students have a little more advantage over the high schoolers because they've been studying more. They're supposed to be more knowledgeable. So to compare them or to put them in a competition, so to speak, for the lack of better words, with a group of high school kids renders the experiment biased. So,
By the way, in America, one of the most powerful forms of this, there is a widespread belief in America that private schools, Catholic schools, Christian schools are all better than public schools. That's a widespread belief. Selection, selection, selection. Because the parents chose that. And so the very fact that parents either A, paid more or went out of their way to get that other thing, you've already got a level of motivation in those parents that the parents that didn't do that, so there is a different degree in terms of family motivation. So that's a form of selection. And yet most people don't think about that. That's just one of thousands of examples of where selection, that one group is not it is not the same because of reasons having to do with artificial selection.
and then another example I would like to add there is, say you discover a logic game, okay, and you wanted to experiment that. So you have two groups, and then you give one of those groups, the chance to study or to do a course on logic. And then the other group, you give them a remedial course in mathematics, for example. Yes, it's possible that both of those groups will have an increased knowledge, but it's more possible that the group who studied a course in logic will be at a more advantage in that experiment that is related to that logic game than the group that just did a remedial in mathematics. So it's just about putting two groups on an equal footing to begin with in the first place. I would like to ask you as a class, anybody, what could be done to curtail this? Can we do anything about selection bias? Yeah, random selection.
Matching.
There's something in here.
And of the two, which is the more effective?
Random.
But we often do matching because sometimes we can't do random. That goes back to the presentations we just had. That was a good question.
Thanks. But then there is another. There's another situation or scenario where this becomes even more complicated. Let's say you have two groups, males versus females. Okay, and you want to know whether males or females who has a better opportunity at college. Okay, you cannot randomly select the genders because if you got to be a male, you got to be a female. So you don't have that much of a latitude there to play with. So that is a concern there too. Testing bias. This is where you give a pre-test and a post-test. And then it said that in a pre-test, students who take a pre-test are more likely to do better on the post-test because of their previous experience with the pre-test. Compare that to another group who didn't have that pre-test. So that could be a testing bias. Now, to solve this problem, I would like to ask you again, how do we solve that problem?
Give everyone a free test.
Yes?
Or you do a modified experimental model where your control groups and non-control groups are some get to treatment, and of those that get to treatment, some get a pretest and some don't. Some don't get to treatment, control group, and half of that get a pretest and half don't. And so then, because it's really a double experimental thing, you can look at the effects of treatment versus non-treatment, but you can also look at the effects of pretest versus not pretest. So those are more complex designs, but it is possible to do those kinds of things. By the way, we often think about the learning effect in taking the math pretest, so that gives them advantage. There's something about taking they kind of learn how to do the math. That's often much more prevalent in attitude tests, because a lot of times if you take a values test or an attitude test, we think that values are kind of an underlying quiescent orientation, and they're just there. But they're not really activated until somebody asks you something about that. They're just kind of unconscious tendencies. Well, if you take a pretest on values, that activates them. And from that point on, it has become an explicit part of you rather than an unconscious. And so therefore, people that have gone through that pretest versus those that don't, now you have a level of conscious awareness versus unconscious, and that can change in terms of pretesting bias. Does that make sense in terms of how that could? So sometimes that's more prevalent in attitude and value tests than it would be in cognitive tests.
Is there a difference between a pre-test and a diagnostic test?
Pretest is generic as to whether it comes before the fact.
Right,
Diagnostics, there are different kinds of pretests. Some are diagnostic, some are just giving baseline. But I think pretest is simply, is it before or after?
Even though you are doing random selection and what have you, you and Ulan's speak of a possible conundrum here, and that is there's still a possibility that one group may be more affected than the other. Anybody can rationalize that? What would be the scenario here? Well, it said that if it is a sensitive subject, even though you are randomly selecting, it's still possible that because of the sensitivity of that subject, it will still have a bias. And as I was reading that, I was thinking more about politics, which is not really politics if you look at it, but it overlaps with politics. And that is Obamacare. I know America is divided on that. So even though you do a random selection, I think it may have a propensity to have an effect on individuals who may have been randomly selected regardless of what group you are in, because of how you perceive, this new law of the land.
Or another example would be if you're dealing something that has to do with some form of abuse, child abuse, sexual abuse, spousal abuse, abuse of pets. There are not huge, but there's a sizable subpart of the population who has been associated with one or another of kinds of those. And if you're studying something like that and there's a pretest or some kind of test on that, it's likely to have a different impact on those families that have a history of that than families that don't have a history of that. Does that make sense? Mm-hmm. So that what he said was a good point. That was what I just gave you is one more example of how that could play out, and you wouldn't be looking for that, but it could be there anyway.
We touched a little bit about this earlier. Mortality is the next one, or attrition. And that has to do with the loss of subjects during the course of a study. For example, research on a group of students begins when they start third grade. Over the summer, half
The typo.
half of the student, HALF of the students, move away. The remaining student population is different from the initial student population. So all that is you lose some of your subjects over time. And I think this has to do with maybe experiments, that are a little protracted. Maybe somebody just got deceased, or they got ill, or they just felt like...
The longer term the study, the more likely mortality can affect it. Does that make sense? Also, again, the bias in terms of how that plays out. Anybody here work in an inner city or phenomena or population of schools where you have a lot of turnover? I know Candy does on Department of Bay, on DOD schools. Well, if mortality would have a greater effect on schools that have a high mobility incidence than schools that are fairly stable. So again, there can be interaction effects between these different things. Sometimes you have two different threats to validity that interact, selection and mortality, that affect it more ways than just one.
Right. Regression to the mean, statistical regression, same thing. And all this to say is that there's a tendency in a group that it will return to the initial starting point. Like, let's say you choose one high extreme, okay, and then you give them a test. They may be hyped up, they may be more knowledgeable, but after a while, the tendency is that they will drop back down to that initial level after the test. So that's basically what regression to the mean implies here.
By the way, have you all heard of the Sports Illustrated jinx?
You told
us
us
about
about
Okay,
it.
that's an example of that one.
I do remember that one.
Yeah, I do. I remember that one.
External validity refers to the generalizability of the result.
Good job.
Okay, that's when you want to expand your finding to make sure that it's applicable elsewhere. You and Orland talk a little bit in depth about this. They went on to say that in here, or we'll talk about later on, population extended validity is the extent to which the result of this research can be generalized to other people. And this is really what you want, okay? But now, when you come down to this ecological external validity, is where the finding is applicable just to a smaller group and not just to a broader group. And that's where you and Olen talk a little bit about. And what it said was that in internal validity, there's a word that is more applicable to that, which is efficacy. Okay, and what that is it speaks of, for example, think about a clinical research done in a lab, where they are testing this drug to see if it's efficacious for this disease, okay, for this treatment. And then, yeah, they found out finally and said, yeah, we got this treatment for this problem. But the thing is, for you to be eligible for this test, normally they have to rule out the possibility, that you have some other illness in addition to that. So only people who have exclusively that illness that this drug is being tested against are eligible for these tests. So when you find out that this drug is efficacious in this case, the problem comes in the external validity, where you apply this drug's effectiveness to the market. And you may find out that even though it was effective in the clinical trial, it may not be as effective in the real world, because someone who maybe has this ailment may have also another ailment which may model the reaction or the effect of this drug. But when this drug was being tested, the efficacy was real because this person only had one form of ailment. But in the real world, it's possible someone may have multiple illnesses. So because of that, that may be a threat to the validity of this external validity under this ecological validity.
Before you go on, what's the APA error there on that slide, repeated 3 times?
The and.
The and instead of the ampersand. Remember, if it's inside parentheses, it should be an ampersand,
Okay,
not an and.
all right, even when it's, all right, I didn't.
Yeah. Okay. That's one of those things,
When it's inside.
when it's inside the parentheses, it should be an ampersand. If it's just in the sentence outside the parentheses, then it's A and D.
Right, okay, yeah.
That's one of those, if I don't like to spend too much time on it, but if you say that 2 or 3 different times, it's more likely to stick,
Well,
so.
that clicked for me. I'm glad you said.
Okay.
Oh, I love this because of the last one.
Okay, lack of internal validity is simple. In order to be even tested
Wait a minute, go back. Aren't you gonna talk about those?
what's that?
But they're
They're on
at
each
six.
slide. He's got it, yeah, he's talking about it.
Well, lack of internal validity?
Oh, okay.
That's what I'm
They-
talking
they're-
about.
Oh,
now.
okay.
Yeah.
So you're still gonna get to those last 2, okay, all right, sorry. I just didn't want you to go on without hitting those last 2.
The lack of internal validity is a threat to internal validity, because in order to be even testing for external validity, it must first have an internal validity. So if it lacks that, that is in itself a threat to internal validity.
Put another way, internal validity trumps external validity. We don't really care about external validity if there is no internal validity. If you've got some result, you don't care about how far it extends or how generalizability if it's not valid in the first place. So internal validity trumps external validity in terms of importance.
Okay, so artificiality is kind of like what I was talking about earlier, about it being applicable to a small group. And then comes the, I'll go to the next, we already talked about this.
There.
Hawthorne. When experimental subjects know that that a new treatment is being used on them, they may perform better than average.
Does everybody know what the origins of the name is on that? Where the Hawthorne effect name comes from?
Hawthorne
John?
manufacturing plant?
The Hawthorne manufacturing plant was
What's it
about
called?
1934, somewhere back in there. Does anybody know the story behind that?
No.
There were some, do you do?
I've heard it, yes.
You wanna explain it, or do you want me to?
There was an experiment done at the Hawthorne, I think it made electrical devices.
Yeah, near Chicago.
Near Chicago, and they were testing, I believe, the effects of lighting on worker productivity. And what they found out was that in the group that was being observed, they started to do a lot better than people who were not being observed. They thought it had to do with increased lighting, so then they tried to turn the lighting down.
They were
The
trying,
effects stayed up.
this was a part of the efficiency movement of the 20s and 30s. And they were trying everything in the world to make manufacturing as efficient as possible, so therefore they could save more money. And one of the things they were trying to figure out, what's the minimum amount of light we can provide, therefore less electric costs, and still get this workers to do what we want. That was what they started out trying to figure out.
They were trying to save as much
Yes.
money as they could, and they determined that the group that was being observed and knew that they were part of the research, even when the light levels were pretty awkward, did far better than the control group, and that the performance was above average, not so much because of what they were doing, but because of the way that they were being observed and knew that they were in a competition.
Well, I'll put it another way. These were line workers, and they did the same thing over and over and over, day after day, week after week. Very boring line work. The very fact that something was going on in their life that made life less boring in that plant, it made life exciting, so it was more fun, they were more productive. So some people have said, one way to increase in productivity is to make work a lifelong experiment that keeps people's interest up. But a better way to do that is maybe you could restructure work so it's less boring, but nobody ever thinks about it that way.
Okay, so Hawthorne is when we are aware that, you know, we are in an experiment, we want to do our best. Now, the way it differs from the next one is when you know that you are up against another group, you want to outdo them. So the pressure is on, I would say, both groups to want to outdo the other. So that's called the John Henry effect.
Now, does anybody know why in American mythology and fables and everything, does everybody know the story of John Henry?
The railroad.
You know, he was considered to be the best at swinging that hammer in terms of driving stakes in railroads, and he was so big and strong and accurate that he could even swing one hand one after the other. And he challenged a steam engine and won, but he had to work so hard to do it that he ended up killing himself. But so anyway, that's where all that comes from.
All right. So, on to the next, which is statistical validity. Now, statistical validity is the extent to which the calculated statistics accurately portray the actual relationships.
Remember what we were talking about earlier with President Bush's, that would have been a statistical validity conclusion.
And that's one of the errors that we're going to talk about at this point, because that's a key one. Okay, so we'll go on to the types of still. All right, these are threats. You've got low statistical power, violated assumptions of statistical tests, phishing, this is interesting, unreliability of measures, restriction of range, unreliability of treatment implementation, and extraneous variance in the experimental setting. These are all threats to statistical validity. Let's begin with the first one. Okay. Low statistical power. There are any number of things that can cause low statistical power, but the most obvious one, the one that is simply going to be that you have a very small sample size. Now, there are others, but that's going to be one of the most obvious ones.
In other words, you might conclude from your study that there's nothing going on. There's nothing statistically significant. And it could be that there is something, but you're missing it simply because your sample size is not big enough. I mean, that's the way that normally works out.
A sample of 3 randomly selected people,
Sure.
generalized, is probably not going to give you the conclusion that there are any people who are 7 feet tall.
Which is why, remember the statement, never generalize from an N of 1? You know, never, and yet that's the one thing that humans do every day, day after day, minute after minute, that is the biggest thing that we do as humans, is that we all generalize from an N of 1. Because humans generalize from their own experience. And they assume when they do that, that they are statistically representative. And I don't know about you, but I figured out a long time ago that I'm not normal, and therefore I shouldn't generalize for myself. But yet, we do it all the time because see, you're agreeing I'm not normal, aren't you?
No, I'm thinking about myself.
So, and that is a major threat to
Yeah.
any kind of research.
Sure.
So, next one. Okay. This is what we talked about
This point.
at this point. Violated assumptions of statistical tests. The biggest example is to assume that things operate according to the bell-shaped curve, which you do see the bell-shaped curve in some things, height, a lot of natural phenomena, but things that are related to earnings or unnatural events or highly unusual events may not follow that model. If you apply it, like we saw with that, you get sometimes get a very, very inaccurate representation. Okay, so we got.
And remember, it's not inaccurate mathematically. The $300 was a correct figure,
Well, that's true.
but it's an inaccurate interpretation that 300 is appropriate.
Mhm.
So it's not that the math is bad, it's that how you interpret the results of that math.
And I'm going to say, just generally speaking, unnatural systems like wealth,
Yes.
level of political power, access to resources, things that can be manipulated synthetically are less likely to conform to a natural bell-shaped curve than
Right.
things
And
like height, weight,
anything where there's oligarchic or power relationships.
And that's actually
Yeah.
a good point. It's worth remembering. So in the next one, phishing. Basically, when you look at enough variables that are unrelated, you try hard enough and you run enough tests, you can find something if you try. And if you do this after the fact, you can build something that looks like a meaningful relationship. That just anecdotally is a way that we can build conspiracy theories. You can say, well, I see this pattern, this particular event happened under a full moon, this particular guy happened to be Jewish, you get into whatever it is, and then you get this big theory. You can build it up far after the fact. Just by looking at enough variables, you can find what appears to be a pattern, but it may not be meaningful. I'm trying to think of a good example of that. We do data mining a lot now, and that will let you look at a huge number of variables.
Well, the correlation matrix.
Mhm.
Do you see how easy it is to do a big, you've got, you're doing a big study, and you've got 25 variables. So you just do correlation matrix, 25 by 25. And that's a lot of correlations. And just on chance alone,
Some of
one
them
out of
will-
every 20 is going to be significant. Well, if you got a 25 by 25, you've probably got, maybe 75 or 100 correlations in that matrix, and so one out of every. So some of them just by chance alone, and some people incorrectly and say, okay, I'm going to look at these because there's a theoretical basis. So, well, I'll just correlate everything. That's phishing.
Basically establishing correlations after the fact.
Right.
And that's really a great flaw. Anyway, next one. Unreliability of measures. If you don't have reliable measurements, then your results will not be meaningful. That's pretty obvious. If we're doing a test of how fast a sports car can go, you hit down the accelerator and in 5 seconds you go from 0 to 300, slow down, first of all. Second of all, because that could very well indicate basically an unreliability in the speedometer, it could indicate an unreliability in the measure, and you can have flaws, errors introduced that could throw things off by a great deal, just if the measurement itself is unreliable.
By the way, no measurement is perfect. We measure scale reliability often with Cronbach's alpha. And the rule of thumb on Cronbach's alpha for internal scale reliability, above 0.7 is okay, above 0.9 is really superb. And to get much above 0.9 is really unusual. But in general, then, the greater the amount of error measurement, the greater the negative effect on everything else that you are doing statistically. So as you have more measurement error, you're making conclusions about things that were not really related to what you're talking about. So the greater the amount of error measurement, the less results the less confidence you have in anything. It's generally not that big a problem unless you go below 0.7.
So can you compensate for that by having a larger sample size?
Yeah, a little bit, but there are also more sophisticated statistical measures that take account of and factor out that error measurement.
Okay.
But that's really pretty sophisticated stuff. That's all really advanced statistics.
Thank you. I thought he was going to choke me for running over. I never know. Never mind. Okay, so restriction of range. Now, if I give you a test and we all make a perfect score, or we all do above 95, this doesn't really tell us anything. It's the range of results is just too narrow. If a math test consists of, okay, what is this? Okay, so if I give you that and we all get it right, it tells us nothing. The range is too restricted to be meaningful, and it can be the other way. There's a test. I don't know if anyone has anyone here ever heard of, let me see, what is that one place? The Isle of Man, which is actually not just an island filled with men. Sorry.
For the cats.
But it's actually, they got a little school there. It's controlled by Britain, but it has some autonomy. They give a test there every year at one of their colleges, which is really more like a high school. The average score out of 100 is 5. It's a famously difficult test. At this point, it's become a point of pride. The average score is about 5% because it's just so brutally hard, and they publish the answers every year on the internet if you're curious. But a test like that where the range is really extremely low doesn't tell you much about performance either. The next factor.
Oh, before you go on, sometimes this can be a design issue. If you look at the Lines dissertation that we were just looking at, her dissertation had her population and sample came from 5 historically black college and universities. And so she had primarily freshmen, a few sophomores and juniors, but primarily freshmen at these 5 institutions. She ended up with restriction of range because on her outcome variables, which were either SAT scores or ACT scores equated with Z-scores. If you remember how to do that from your stats class, and which are standard scores. But in fact, there's a restriction of range because everybody who was in that population got into a 4-year college. So kids who didn't have good enough, kids who went to associate or junior colleges or associate degree, generally less well prepared, less good grades, and less high scores on these SAT and ACT. Kids that didn't go anywhere, they just went through high school, or they went to high school and got a job, or dropped out of high school. All of those are segments of a cohort that would be generally lower scoring than the ones that get into a 4-year college.
Okay.
They were all excluded from her research design because she's sampling freshmen at a 4-year college.
That makes sense.
So do you see that? So now her results usually were around 0.2 in terms of correlations, which were significant and important. But what if she had done that parallel study when the kids were still 15? Now you'd have to adjust the questions for a little bit younger population. Do you think that she wouldn't have had more likely higher responses? Let me give you an example. One of the variables that she used was parental educational push. Did I talk about this? I don't think I did. Okay. And when we were doing that, we brainstormed what we and others, like ourselves, what were strategies that parents do to push their kids. Well, we came up with things like playing phonics games with them, reading to them, monitoring their homework, watching Sesame Street with them. So we came up with a whole bunch of those, came up with 10 items. Because all of the stuff that we were doing was theoretically based, most of the new instruments that we designed, Juanita and I and another colleague that was on our committee, most of them factored right as we intended, which is pretty unusual for a first cut. But I think our success was because what we were doing was theoretically based. On that one, a 10-item scale of those things that we missed. We flat out missed that. So instead of being what we'd intended, the factor analysis showed we didn't have one 10-item scale. We had an 8-item scale and a 2-item scale. And it is very unusual that a 2-item scale is long enough to have adequate reliability, but these were so tight together that they did. So what had we missed? We thought we had a scale. Turned out we had an 8-item scale and a 2-item scale. Well, you go back and you look at the wording. Here's the wording on the 2 items that factored by themselves. My parents pushed me, this is almost word for word, my parents pushed me to take all of the advanced math and science classes in my high school. The other one, my parents pushed me to take all of the advanced placement classes available in my high school. And everything else was about reading and phonics. And so what we had and what we had missed, we had a parental elementary preschool educational push and a parental secondary educational push. We hadn't realized it until the factor analysis told that. All right, so now, how does that relate to restriction of range? Let me ask you this question. When we did, her dissertation was really 2 dissertations. One was to create and validate all of these scales. The other then was to see which ones of those had an effect on the Z-scores representing the SAT and ACT scores. I will tell you that in the final regressions, one of those 2 variables, the elementary push and the secondary push, one of those was significant and one was not. Now stop and think about that for a minute. And which one do you think was significant and which one was not? And I will tell you that the answer is related to what we're talking about here. Somebody besides Brant?
I would say the elementary would be significant.
Anybody else?
It could be either, I think.
I kind of thought maybe
I think you'd
advanced
have a
placement.
restriction of scores with the high school ones, if they're going to 4-year schools.
Anybody else? All right, you want me to explain why? The secondary educational push was significant. The elementary educational push was not. All right, now here's what we found when you look at the data. What do we know about parent involvement? We know that parent involvement is pretty strong for elementary kids.
That's true.
What happens for any of you that work at middle school or high school, what happens to parent involvement?
Drops, yeah.
Plummets.
All right, so what we found was, remember, all of these kids, restriction of range, we didn't have the bottom part of the cohort in terms of achievers. We had the top part of the cohort. Actually, we had restriction of range at the top, too, because Juanita is black, Ella Simmons, who was one of the other committee members, is black. Both of them had connections at Howard and Spelman, and what's the other, there's another elite male college, Howard,
Brown,
and what?
is it Brown?
Not Brown, anyway, there's 3 of them, the Spelman and then the 2, Howard and another one. Anyway, they had connections at all 3 of those, but all 3 of them turned us down. So it turned out that the schools we got, Kentucky State, Fisk, Alabama A&M, Tennessee State, and another one. Any of those were all very much working class, lower middle class, historically black college universities. So the three high level ones, the Ivy historically black colleges, all turned us down. So we didn't have the really high end, and we didn't have all the kids who dropped out of school or didn't go to high, or just finished after high school, got into associate degrees. So we didn't have the bottom.
Why did they turn you down? Just didn't want to mess with you?
Well, I don't know whether
Spelman Morehouse?
no, it wasn't Morehouse. It was Spelman and Howard, and there was one more.
Tuskegee?
No. Anyway, whatever. Anyway, huh?
I don't know why Clark, but I don't.
No. Anyway, but anyway, all three of them turned us down. So we didn't have the really high Ivy type scores. We didn't have you didn't have kids with 1600s or 1400s, combined. You just didn't have those kinds of kids at the schools we went to. So anyway, if you look at the responses, my parents read stories to me. My parents played phonics games with me. My parents monitored my high school. All of these kids answered 4 or 5. Restriction of range. But on secondary, parental involvement goes way down. There weren't that many kids that said that their parents continued to push them at the high school level. And both of those, advanced placement classes and pushing them to take math and science. So that was spread out. You had scores all the way from 1 to 5 on that versus scores of 4 and 5. So the restriction of range tells you that the elementary educational push was not significant. That doesn't mean it wasn't important. It just means that because of the restriction of range, you didn't have any correlation there because everybody answered 4 or 5. Now, if we had measured those same scores at age 15, then you would have had kids that said, no, my parents didn't read to me. My parents didn't play phonics games with me. You would have had the entire gamut. And yes, that is an important construct, and it also would have been significant. It wasn't significant in this pool, in this population, because all those kids, remember, all these parents got their kids into four-year college. And the parents reflected that and turned, everybody, I don't think there might have been more than 1 or 2 kids in that entire group that gave less than a 4 or 5 on that one. But the scores were all over the place, 1 to 5, in terms of continuing to push at the secondary level. So there's an example of how restriction range not only is its meaning there, but it can affect the entire design of a study. Oh, by the way, the Yoconda Guerra, and that's another one of the dissertations you have. She did a qualitative study, focus groups of Latino kids in 3 community colleges and U of L and UK and Northern, in 3 community colleges. And she studied freshman Latino kids and the barriers they experienced getting into college. Same thing. Because whatever they found, these kids actually got into college. Versus, what about the Latino kids that never got in the first place? You would assume whatever barriers that the kids that got in, the barriers would have been more so for the kids that didn't get in. So you see, even a qualitative study could be subject to those same kinds of restriction of range. Does that make sense? By the way, what we've just been talking about, restriction of range, that's a design that a lot of people don't, that's a design issue that a lot of people do not consider. That's pretty sophisticated stuff to think about that.
Last 2. All right, last 2. We were on unreliability of treatment implementation. Simply put, whatever treatment you've got, if you don't implement it in a well-controlled, in a reliable manner, gauging its effectiveness wouldn't be very meaningful. I give the example of medicine. If you're testing a new medicine, you don't give it consistently, the dosage isn't consistent, the way that it's administered isn't consistent, any problems like that, are gonna really undermine the effectiveness of any study that's to gauge the impact of it.
And by the way, one of the real problems in terms of medical controls is the population of adults who have some mental illnesses.
Don't take the
It's
medicine.
very difficult to get them to take their medicines consistently. It's a perfect example of that.
And experimental diets, people have a
Sure.
tendency to not follow them, anything like that.
Especially if it means it's eating healthy foods as opposed to unhealthy foods.
Yeah, that's true. And the last one, extraneous variance in experimental settings. Factors unrelated to treatment, such as settings in which a treatment is administered, may increase the likelihood of an error and make it less effective. I give this example. If you're testing a training regimen for runners, they're not, even if they really have improved, they're probably not going to perform wonderfully in the middle of an ice storm. It might be amusing, but it probably won't be very productive.
By the way, a more realistic one is anybody who works in a high school, a large high school, which is a testing center for ACT or SAT, and they can anybody who's done that very long can have a story about the morning that kids showed up when they were doing construction or something next door, and it was just this insensate jackhammer and all that kind of stuff. And the testing goes on, and anybody who's been around that all of the kids who sat through that 3-hour session, with that jackhammer and other stuff going on, it had to have a negative effect. And yet, too bad, so sad, because the testing center back in Washington, and wherever that's from, they're not going to say, oh, gee, you mean you had to do your test under, with a jackhammer in your ear? We'll give you another chance. Sorry. But see, that's a perfect example how that would be a threat to validity. And anybody who's been around that kind of stuff can give you examples of something like that.
Well, the final thing I'd mention is I would imagine that during periods of prolonged deployment that maybe students'
Oh,
test scores are going to
yes.
go down in a meaningful way that doesn't reflect decrease in ability. It's just there's family stress and all that's going to really hurt them in any number of ways. So I think that really pretty much sums us up, and that's it. Is it not? Yes.
My turn.
Okay. Excuse me. More power off, or just switch back to the vision. Oh, yeah, thank you.
When playing with this, call Trudy. That's our
Oh.
solution.
Great. Okay.
Brant,
Yes. Oh, what a pity.
are you going to give that to Trudy?
Who's next on
Trudy.
the list?
Trudy is going to spend a little bit of time on her own personal thing.
Oh, okay. Here you go. Good luck.
Thank you.
Is that still flashing intermittent green?
Yes, it is.
Well, it should be. It's not?
How do you turn it on?
Well, it should have been already flashing green, is it not?
It's flashing red now.
Well, then give it here. Push it. See that little button? Push that right there.
At the front?
Yeah, push in on that and hold that about 4 seconds. All right, and then let up. Should get intermittent
Yeah,
green.
it's green now.
There you go. Do we need to take 2 minutes?
Everybody's leaving us.
To go to the restroom would be great.
Why don't we take 2 minutes before we start?